You can see it, right? Okay. So thank you very much for the introduction. In this talk, I will try to discuss in this 15 minutes about some issues related to bias and fairness in artificial intelligence and machine learning. And I will try to define first problems that are related to this field, give some definitions, some possible solutions, and in the last part, some future directions using open data in a fair ecosystem. And fair is capital for a reason that we will see in a few minutes. So just a little bit of background. Why am I talking about these issues related to bias and fairness? Because machine learning is not just something that is considered as an engine behind, for example, spam filters. It's something that is around us every day, and it's used to, for example, to filter loan applicants, to filter applications. It's used by human resources, so it has a great impact in our lives. So it's important to understand how they work, if we can understand how they work, and if we can correct some of the issues that we find. So I will start first by defining what's explainability in machine learning. So this is a game that I play with the students of machine learning courses here at the university. And I give this picture and then I ask them, what is this animal? And it's easy because they immediately say, okay, it's a tiger, of course. But the question, why is this a tiger? So it takes a little bit for us. Maybe kids are much more happy to play this game because they are more, they are more open to give answers even without any particular reason or justification. So we define tigers according to, for example, the fur, the stripes that they have, the whiskers, the teeth. So we have an intuition of what a tiger is. We can explain what we consider a tiger. We have an abstract model of a tiger, but a machine learning system cannot explain why this is a tiger. So a machine learning system, an AI system, has actually a vector, a series of features with values that are correlated to some features of the tiger. And it's hard to tell why some answers are given by one of the automatic systems. And this is very important in some situations. So this is the COMPASS system. In 2016, it raised a lot of attention because it was a system to predict whether a person in jail was able to commit again another crime. So in this case, we have two people, Vernon Prater and Richard Borden. One is high risk and the other one is low risk to re-offend again. And if we see why we have a high risk and we see at the feature that were behind these two people, there's no reason why we had a high risk for the girl. And in fact, was rated high risk for future crime after she stole a bike, and that's all. And she never committed any other crime after that, while the other guy committed another major crime. So this raised a lot of attention because there was something hidden in the system that was not capturing the actual features to predict crime. So there are common distortions that can produce this unfairness in systems, and could be bias encoded in data. So things that happen in the data, even though we don't know it directly. The fact that when we train systems, we try to minimize errors. And if we try to minimize the overall error, we will see that we have problems. And also the need to explore new data. So starting from the bias encoded in data. So there was a very interesting discussion going on online between two important people, Pedro Domingos in machine learning and Andrew Gelman in statistics, in December 2020. It was about whether machine learning algorithms can be biased or not. And Domingos said that can be, since machine learning systems are actually formula, can't be racist or sexist any more than the formula itself. While the problem is that, this is partially true, but the problem is that it's not a formula, is that we feed data to the formula. So if the data is biased, then the output of the formula will be biased too, and that's the big problem. So we have to find where the bias is. So bias encoded in data could be historical bias, representation bias, sampling bias. So this picture on the right-hand side shows you the distribution of one of the largest databases of images called ImageNet, and it has a huge disproportion of images coming from the United States of America compared to the rest of the world. So if you want to train a system, you will be biased towards that particular country. And you have to take into account that once you present the results, if you want to be fair towards the other communities or towards the other countries. There's also the problem of minimizing errors. So machine learning systems try to predict the future or predict the output of some question by looking at the overall error. Sometimes, of course, you can adjust it, but if you try to minimize the overall error, if you have groups or subgroups of items in your data set, for example, we have fishes that looks towards the left-hand side, and just the one group with one fish that looks towards the right-hand side. So you may be biased towards the majority, because the equation that optimizes your system tries to optimize the overall situation. It will be biased towards the fishes that looks towards the left in this case. So a group line classifier trained to minimize this overall error, it will fit the majority population. It will be biased, so towards one of the other subgroups that you have in your data. And the last issue that I'm trying to discuss here is the need to explore. So suppose that you found some bias in your data, okay? So in many important problems, the data fed into the algorithm depends on the actions that the algorithm takes, okay, during the training. So what if we want to explore subgroups that we have never seen before? Okay, so in order to rebalance this proportion, for example. Now, it may be problematic also, this countermeasure, because there are at least two ethical questions that can be raised. So one is, what is the cost of exploring a subpopulation or more than a subpopulation? Okay, so there's an economical aspect, or a time aspect, or a resource aspect whenever you want to explore new areas in order to rebalance things. Or in some cases, which is even more difficult, are some actions to this new area of exploration immoral, like for example, in medical studies, you want to find whether there's a correlation between smoking and lung cancer. Is it immoral to start asking people to smoke to see if something is going on or not? And how much that is slow learning? So if this is immoral, so if I'm not sampling or looking at those subgroups, how does this slow learning affect the overall performance of the system? So as you can see, there's a lot of problems going on with machine learning and the bias and being fair. And that's also this cycle of bias, or this vicious cycle of bias. Starting from data, you have bias in the data, and then you build a model on the data, and then you may introduce some algorithmic bias, for example, if you want to minimize the error. And then from the result, you also have a presentation bias. So once you have the results, the way you present results to the user may affect the way the user interprets the result of the problem. So you can affect the user, and there is a cognitive bias. So the user will produce more data, but if the user is biased, then the data produced by the user is biased, and then you have this cycle, which is very which influences positively or negatively the bias. So we have to take care of this problem. So what is fairness in this framework? So there are I don't know how many fairness definition here we have. I've shown you a paper, or actually it's a tutorial in one of the conferences, the most important conferences in this area, which is the Conference on Fairness, Accountability, and Transparency, a tutorial on 21 fairness definitions and their politics. So there are plenty of definitions. I just summarize some of the idea of fairness. So we may have a statistical notion of fairness where we fix the groups that we want to observe and try to make the analysis of these subgroups fair in terms of number, of statistical parity. Or the individual notion, so trying to build constraints that bind on specific pairs of individuals. So we are looking at individuals rather than groups. So these two notions have pros and cons. So for example, the statistical notion, it's easier to compute, but it has a major drawback. So you cannot optimize all the measures that you want to optimize in a machine learning problem, because there's a sort of inverse relations between, for example, true positive and false positive. So you cannot optimize the system in the best possible way. While the individual notion is, of course, better, but it contains a lot of information about groups that sometimes you do not have. So can we have the best of both worlds? Well, it's hard. As you can imagine from this very short presentation, there are a lot of problems. It's hard to define a unique measure of fairness. So is there any solution? Well, there's not just one solution. There are different solutions. So for example, this Equitas approach, it's an open source initiative for auditing your machine learning system and your data set. So you start by defining what aspects you want to compare or you want to be observed in terms of fairness. And then you go down this tree, and then you are suggested a measure that you want to optimize for that particular reason. So you can see there's not a unique overall measure that tells you whether you're doing right or wrong. There are specific measures for a specific or a peculiar setting. So it's not easy, but it's important that we acknowledge the fact that we have this problem. So what's next with fairness? Now it's capital fair. You heard in the previous presentations this term. So it's part of the European Open Science Cloud Association, which is an initiative, a European initiative for the open science. And the idea, one of the ideas of this association is the idea of an implementation of a web of fair data, where fair is findable, accessible, interoperable, and reusable in order to combine open data set. But there is also a problem with that, and this was documented in one of the deliverables in one of the pilot projects of the EOSC association. So just quoting here, the FAIR principle, although inspired by open science, deliberately do not address moral and ethical issues. So it's important that each one of us that produce data and build a data set and make this data set available are responsible for what's inside, or maybe we have to take into account the fact that we may have bias when we build a data set. And it's important to know that, to test if there's anything going on in terms of bias and fairness in our data set. So concluding, if the data is a product of social and historical process. So data is biased by default, I would say. So it's important to understand how we can mitigate this bias in order to have a fair artificial intelligence. And it's also important to understand that there may be feedback loops. So we have data, we try to mitigate bias, but instead we are actually doing the opposite. So we are introducing bias. So it's important to acknowledge the fact that there is a problem, and it should be, and we should intervene when we see something going on. So to finish up, if you think you are not biased, go to this survivalofthebestfit.com. It's an open source test to show you that even if you do not want to be biased in any way, there will be some correlations in the data that will force the system to capture something that is going on, which is wrong. So it's important to have a feedback from the human. So thank you very much. I think I'm on time. Thank you.